Hello again and welcome to AstroPrinter. My name is Liam. So today we're going to talk a little bit about 3D printing, and you've gotten your new printer. It arrives, you open a box, you follow the instructions. Hopefully they were clear enough so you can assemble it without any problems. Some are good, some are bad, it varies. You must remember that most of the printers are actually manufactured overseas. But you got instructions, it went together nice and easy, or maybe not so nice and easy, but you eventually got it assembled. All set up. Now what? So, you've got your printer assembled. Now ignore this. This is a mod I added to my printer, but I'm going to leave it in for now because the basic process is the same. You've gotten these weird pliers. These are called level cutters. You will need these. You probably got a short spool of filament. Hopefully you got a spool of filament. Some printers supply companies or printers manufacturers today are sending in printers with some wound up loose filament spun into a ring that you have to use in your printer. That's terrible. If you're going to get a printer, make sure you get an actual spool of filament with it. And it may not be from the manufacturer. Go out and buy some. There's lots of good manufacturers out there. Go check the reviews online. I've used G-Tech, I have used IC3D, I have used Sunlu, I have used various different types. Most of them are work, but check the reviews online when you go buy that before you buy. Chances are you're going to start with PLA. I recommend everybody start printing with PLA. That's the first thing you should ever print with. Move on to more exotic materials when you get the hang and get used to printing, because they all have their aspects to tweak and so on. PLA is the easiest material to print with. So start off with PLA. Now, if you got a spool like this, good. I'm not going to use this because I have other spools that are already open and this is not, so I'm going to cast this aside. And so what I'm going to do is, I have a spool of filament that I have on my own. I'm going to use that, it's already opened. And the process is the exact same. So you got a new printer set up. First thing you do once you build your printer, you check the printer voltage. Generally, a printer is shipped with the voltage switch set to 220, right? The reason why it is shipped with 220 on the voltage is if you plug a 110 to a 220, there's going to be no problem. If you plug a 220 to 220, you're good. But if it's set at 110 when it ships, you plug a 220, if you're in Europe or other areas in the world that use 220, you plug 220 into 110 machine, you release that magic smoke, you see smoke coming out of your printer, printer's dead. You just destroyed it. So make sure, before you even power it on, before you even plug it in, you check the voltage to make sure you set the voltage switch on your printer, and every printer has one, to the right voltage for your locale. So what do you do next? Well, first thing you need to do is learn how to level your bed. Now, I'm going to show you how to level a bed first cold, which you don't really need to do, but it's good to get it very close to where it needs to be cold, and then later on come back and re-level it when you've heated the bed and the nozzle. And I explain the reason why in a moment. So you got your printer, you have your y-axis, your x-axis, and then you have this gantry goes up and down, which is your z-axis. This is your spool holder. In my case, I have a filament runout sensor, and I've modified that to move it to a different location. But yours will, if you do have one, it'll be mounted probably here, or it could be mounted on one of these axes. If you do have one, not every printer comes with them. You have your LCD screen and your dial. Some of you will have touch screens. If you do, everything's a touch button on the screen. This is not a touch screen, but the concept again is the same. And your printer documentation should show you how to go in and set temperatures and so on. But before you do any of that, your print surface, if you have a glass print surface, it comes with a smooth side and a rough side. The stipple side, the rougher side, should be facing up. I'll explain why later on why you use the smooth side. But the stipple side should be facing up. If you have isopropyl alcohol, get some isopropyl alcohol, get a cloth, give it a good amount of isopropyl alcohol, clean that surface down. From manufacturer, the print surface will have some oils and so on, and maybe some even adhesives on there from the plastic or tape coating that was on the bed to protect it. So clean that bed down and give it a good cleaning with isopropyl alcohol to get it clean. I know isopropyl alcohol is a bit of a prime this year, being 2020 and the COVID, but still, use some, clean it down, get a good clean to give you a good clean surface to start from. Next thing you need to do is rough level your bed. So you need a power on the printer and you need to home the printer. But before you do that, under your print bed, which is right here, you have 4 screws underneath. 1, 2, 3, 4. Tighten those down so the springs are fully compressed. And the reason why I'm telling you to do that is you want the bed as low as possible with the springs compressed, so when the printer auto homes, you make sure that the printer nozzle is not impacting on the bed when it comes down. So you want to get them separated and let that happen first. I've already leveled this bed, but you basically crank all of these down so they're tight, and the way it works is it's the opposite way, so it's righty-tighty. You actually spin, you have to imagine you're looking at it from underneath when you do the righty-tighty and lefty-loosey on all 4 of these. Tighten it down so the bed is compressing that spring. There's a little spring in here. I'm not sure if you can see them or not, but there are springs in here. I have little orange springs in here. Some of them will not be orange, they might be white or just silver. So crank it down, not tight, but actually put it down so the springs are fully compressed. Once that's done, you power on your printer, and the voltage is good. You turn your printer on. Now this is going to be a bit noisy because I do not have silent fans or anything on this printer. So let it start up. You go into the menu, you go to prepare, and you do auto home. And auto home will home all 3 axes, X, Y, and Z. Some printers auto home at different speeds. So as you can see now, my Z axis is coming down to auto home. Now you also need a sheet of paper. Now, not heavy bond paper. The paper you want to use is paper that's coming out of a photocopier. If you use heavy bond paper, it's going to give you wrong offsets, the wrong distance between the nozzle and the print surface, and it's not going to be not going to be what you want. Now, this printer does not have auto bed leveling, and a lot of printers out there do not. So I'm going to show you the non-auto bed level. I will at some point do another video. I have one printer that has auto bed leveling, and I will go over that process as well. But for now, I'm just going to do the manual process. So you have it auto homed. Ideally, now there should be a gap between your glass and the nozzle underneath. Now, the nozzle right now is cold, well, that's okay for now, but there will be a gap there. And that's okay for the gap. The reason why is you want to get that gap by loosening these now, which is loosening them. You want to raise the bed up so that the nozzle is about 4 to 5 millimeters away from the glass, the top of your build surface. So just manually bring it up there to get it roughly there. And if you find that the spring is not at least 50% released, and you're at that distance, you need to decrease that. And the way you can do it is, the reason why it stops at a specific point is on one side here you have what's called an end stop. There's a little switch. That switch will actually stops it coming down. And what you do, it stops the Z-axis. So you may have to sometimes adjust the Z switch in this printer. It's this unit right here. There's a switch right in here. Hopefully you can see that. And you may have to move that switch up a little bit. So the ultimate would be to have, with the springs fully closed down, about 3 or 4 millimeters of a distance between the glass and the nozzle, or your print surface, whichever that is, and the nozzle. That's where your starting point is. If you're 3 or 4 millimeters away, we can actually use the springs to adjust, these knobs to adjust your level. If you're more than that, let's say if you're about 8 millimeters or a centimeter away, then you need to actually move your end stop switch up by loosening the 2 screws here in your end stop, loosen them, move it up a fraction, and then then auto home again until you get to that point when you're about 3 or 4 millimeters away from the bed. And when you're at that point, now we can start using the 4 knobs on the corner of the bed underneath to do our leveling. So I'm actually going to crank these down, not fully but somewhat, to give plenty of space. Now, to level your bed, there's one other thing you need to do. Is you go into your menu, you need normally the steppers motors are enabled once you do the auto home. So you need to disable those steppers. So you go to auto home, into your menu, go down to prepare, and choose disable steppers. If you have a touch screen, your menus might vary from printer to printer, so follow the instructions that come with your printer to disable those steppers, and that allows you to freely move these axes. Now, you're not going to move the Z at all. We're only going to move X and Y. Sorry, X and Y. So you want to move your nozzle in, so it's about 2 inches in, or 2.5 inches or so in from each corner, which is about maybe 5 centimeters or so in from each side. And when it's in there, you take a sheet of paper. Remember, this is a rough one when the bed is cold. Put a sheet of paper underneath the nozzle. You see there, I can't get under, so I need to tighten this down more. I should tighten all these, maybe, is my guess. Just for now. You see the way my sheet of paper moves very freely underneath? Let me move it in front. Okay, so it's not like you do not feel the nozzle rubbing on the paper. So, moving the paper, you loosen these adjustment bolts until you feel the nozzle rubbing the paper, giving a little bit of resistance to the paper. Once that's done, slide the head to the opposite side. Again, over here it's loose, so I'll loosen here again. Should be slightly catching. Okay, now I'll move it to the back section. I'll do the same over here. I'll loosen till it's slight friction. You can actually feel, it should rub the paper, but not to the point that it's actually digging in. If it digs in, you've actually had them too close. So I have resistance there, perfect. And then I'll move across on my other corner. And this is actually impacting, so I'm going to loosen it a little bit. Okay, there's a slight rub there. And I want to get it rough. The reason why I'm only doing it rough for you right now is because when I actually heat the bed up, the bed and the nozzle are going to expand because of heat. As you know, things heat when you heat stuff up. Metals, most materials expand, and when you cool them down, they contract. So this is going to get hot, so it's going to expand and going to change a little bit. And then once that's done, and we have it leveled, we're going to re-level it once it's hot. So I'm going to show you how to get it hot. There's two ways of doing this. You can either manually go into the menu and set each nozzle and temperature on bed to the temperature you want yourself. Generally, PLA is about 200 degrees. It'll vary a little bit from material to material and manufacturer to manufacturer, but generally PLA is 200 degrees, and that's a good temperature to start with. And the build surface, normally people do around 50, 55 degrees. Now, most printers have an option in the printer to preheat automatically, but I prefer to set it manually, but you can use a preheat and it will do that. The only thing about the preheat option in most cases heats the bed and then the nozzle, or vice versa. It never does them both at the same time, which is why I like to set them manually, and then I can actually set the temperature of both and they both heat at the same time. So I'm going to go into the menu, go down to control this time, go to temperature, select my nozzle, and set my nozzle to 200 degrees by turning the dial. Hit go, and that's 200 degrees, and then go down to my bed and set my bed to 50, say 55. And then I'm going to go back out again to my main menu, because in the info screen I can actually see the temperatures. So my temperature right now is my nozzle is 58 degrees and 61 degrees, and my bed is at 21 and rising. And once it hits about 30 degrees, you'll actually start feeling a temperature difference. So let's give it a moment to heat up. And as I said, now we're actually going to re-level the printer again with the sheet of paper, and it should feel you should feel a rubbing and some resistance, but not to the point that it's actually, if your nozzle is digging into the paper, you actually the gap between the paper and your nozzle is actually too little. You need to increase the gap, and so you actually tighten these up again, which actually pulls the bed down. Because when you tighten, the bed gets pulled down. When you loosen, it rises and gets closer to the nozzle. So 164 and 35. Now, as I said, in my printer, I have a slight modification, which is this, is because I have a filament runout sensor, and I didn't like where it was positioned, so I designed a little modification for my filament runout sensor to move my filament runout sensor up away from at the top of my Z gantry. Some people will come with printers where the filament sensor is actually off to the side of the printer. So you hang your spool over here and you have a filament that feeds into the side. Some have them center on top, hanging off the back. Some printers, like some of the Creality printers and so on, has an external control unit rather than using the control unit like here. They have it in a separate box at the side, and your filament spool holder hangs on that. And some of them do and do not have filament runout sensors. So we're at 200 degrees in the nozzle and 46, 47. We're close enough to try it. They're almost at proper temperature, at print temperature. So again, my sheet of paper, my nozzle a little bit in from the edge. It goes in. You see there's gap there that wasn't there before. So I'm going to loosen this up again to get my gap, to make sure I get it rubbing. Now I'm going to show you if it's too tight, what you get. I don't know if you can see that. There's a line on my paper. That means your nozzle is actually too close to your bed. So you want to have the gap so it's actually rubbing, but not actually leaving an indent on your paper. Okay, that looks okay. Maybe a little bit. And then bring it across here. Again, loosening it out. So it's... one other pointer. When you're doing your bed and your nozzle, adjust the screw and take your hand away when you're testing. Don't test it with your hand right there. Your final test should have the hand away from it. The reason why is you touching this will actually increase or decrease the distance as well, because you're impacting, you're going to make movement on the springs. So you actually move your hand away to verify. So again, just get it nice, a little bit touching there, perfect. And I'm going to move my gantry forward. And I'm going to put my paper in again, and I'll again remember it was right before, but I need to adjust it. There we go, that's good. And the last corner, again, needs to be adjusted slightly. So, done. I can actually take out my sheet of paper. Put that aside. Now the one thing I'm going to do here before I auto home anything, I need to load my filament. So I'm going to move my Z-axis up. So I'm going to go to my menu, go to control, go to prepare, go to move axis. Again, this might slightly vary on your own printer depending on the menu system. I'm going to move Z because I want to move my Z-axis up higher, move Z. I have options of move 10, move 1 and move 0.1 millimeters. I'm going to choose 10 because I want to move it up a fair bit. I'm going to move 10 and I'm going to increase it by about 30 millimeters, about 3 centimeters up off the bed. Okay, so it moved up. Now I have some clearance underneath here. The reason why I needed a clearance is I'm going to load filament and I need to have clearance underneath to do that. Now, as I said, you probably have come with a different spool or some loose filament. I'm going to use a spool that I've already opened, and I'm going to, the first thing you do is get your level cutters. At the end of your spool, there's going to be a little kink. Make sure you get a nice straight area. Cut it at 45 degrees. The reason why you cut it at 45 degrees is you want to be able to get it inside into the nozzle without getting snagged. And if it's flat or if it's damaged in any way and it's not straight, you will have a problem. And it's also a good idea just to get the end of the filament and pull it between your thumbs and forefingers. Try and straighten it out a little bit to make it easier. Mount your spool. In my case, I'm going to feed it through here before it goes into my filament sensor. Now I'm going to feed it into my filament sensor. And you see the way it's getting stuck sometimes? If that happens, the solution is to pull out some extra filament and actually bend it and twist it. So let me show you by what I mean. I'm going to pull out more. and turn it. And by rotating it, you get it through your sensor, if you have a filament sensor. And I'm going to pull it down. Now this printer is a direct drive. Bowden style printers are slightly different, and I'll do a different instructions on the Bowden style printer. But the basic concept are the same, just the way you load material is slightly different. So you take this. In my extruder, on my hot end here, I need to pull back this to load filament. In the Bowden style printer, there's an arm you actually squeeze. So you take a material and you push it down through the hole, and you push it through manually until you see some filament oozing out the bottom, like here. And now to make sure it's set up correctly, you can always go back in here. When we said move axis, go back out to move axis, and you can actually move your extruder. So you go to extruder and say move 10 millimeters, and then do one turn, and that's 10 millimeters, and it will actually start extruding 10 millimeters of filament, and then stop when it's complete, like so. Now I've loaded filament, so everything's hot, and I've loaded filament. I do not want to go near the hot end. Now there's a bit of a gap here, and I could probably reach in with my hand, but for safety sake, you should never. You can actually use these, or I like to use a pair of tweezers also, to come in, grab the filament, not the nozzle, and pull the filament out of there, like so. This is waste. But what you're laying down on your printer is you're laying down little strands of filament like this, and they stick to each other. That's how FDM printing works. So it's layer upon layer upon layer of these strands of filament, and they stick together, they melt and stick together. Now we're done here and we're ready to go. We're going to go back to our menu. I'm going to go, instead of move axis, we're going to go out of move axis, and we're going to go into prepare again. And in prepare, we're going to do auto home, because it needs to start from its home position. We do auto home. And the printer goes to its home spot. And it goes to the home using the end stops like I described earlier on. There's an end stop for X, Y, and Z. The Y is at the back, the X is actually at the end, and the Z is actually down here. Now we're ready for our first print, because we have filament loaded and so on. Now, chances are when you get a printer, you're going to have a printer. It's going to come with an SD card, a micro SD card. Some printers come with full-size SD cards, but in most cases there's going to be something on that SD card that is printable. It's going to have a .g code file. And that G code file is basically the instructions, the X, Y, Z movement instructions, and the E movement instructions actually for extruding the material, for the printer to give the printer the instructions of what it has to do. And that's basically mathematical maneuvers. So you put your SD card into your SD card. Most of the time, the SD card goes in upside down. Do not put it in this way. Okay, it will not work. You need to go in upside down in 99% of the cases, because the board is mounted up here at top, underneath inside the casing, and the card goes in upside down. Plug in your SD card. You should start reading the SD card straight away. And you want to go to your main menu again. And from the main screen, we're going to navigate down to print. So we're going to hit the button. And we look for print from FT, or some of them say print from SD. So you move down to print from TF, and from here you will have at least 2, probably 3 files. It varies from manufacturer to manufacturer that have a .g code extension. So you'll actually, I'm going to turn around and choose one of these. Most of them have something like a Benchy or something like that, so I'm going to see what I have, because this is my own SD card, so I have other stuff on there. I don't want to vase, it takes too long. Okay, let's do an XYZ cube. So this has got an XYZ cube on the SD card. So I'm going to select the cube, and what it's going to do is it'll auto rehome again, and then just very quickly, and then it'll go out and start printing. And the first thing it does is creates a line down the side of your printer. So some printers will do it on the side, some will do it in the back, some will do it across the front. It depends on the way the software was set up, or the code file was sliced. So I'm going to do, oh, I lost it again. Print from TF. And I'm going to, the XYZ cube. The XYZ cube is basically a calibration cube. So I kick that off. And now, the first thing it's going to do is I'm going to lay down what's called a brim. See that, doing a line across the front? Other printers don't do the line around the front. Now this is creating what's called a brim. And the good thing about a brim is you can check it as it's laid down. It should feel like a fishing line on the surface. And if you check the brim, and the brim is sticking well to the surface, chances are you're going to be okay for your print. But you need to watch. I've gotten into the habit of watching the first layer. It's a bit of a bad habit I've got into, but there's good and bad in it. If you have confidence in your printer, it shouldn't be an issue. And once you learn to use it, but I always like to watch the first layer go down to make sure that the first layer is good. If you have a good first layer, chances are you're going to have a really good quality overall print. So I'm going to let this finish, and I will come back and show you the result, and maybe I'll even show you what the purpose behind the XYZ cube if you have an XYZ calibration cube that comes with your printer. So hold on a moment and we'll jump ahead and we'll come back in a brief moment to showing you the completed product. Now that your print job is complete, you can either manually pop it off by hand. Normally when the print bed cools down it comes off by hand, or you may have a requirement to use your spatula just in case, but generally it pops off by hand just by grabbing it, and you end up with a nice print surface. And the goal is to end up with a nice finished Z, X and Y. That's pretty much, and then this base, because it comes with a base, simply pops off. And obviously the base where it's attached is not going to be as smooth as the actual finished top, but it's still pretty good quality. You can quick rub of sandpaper if you want to finish it off, but this is a calibration cube. The question is what you use a calibration cube for. Well, the calibration cube is used to measure the accuracy of the motion of your printer on your X, Y and Z. So you normally use a set of calipers, and on the X axis you take a measurement, and mine's exactly 30 millimeters on the X. Check again on the Y, again 30 millimeters, and on the Z axis it's a fraction over 30, so the Z is slightly off, and there is some, as I said, there is some inconsistencies on the base here that needs to be smoothened out, so that's probably associating for the slight variation. So this is why you would print a calibration cube to validate why your printer, its steppers, its motion, and its the distance it believes it has traveled. Now, if you find an instance that one of your axes is way off, like it's off by about 3 millimeters, or it's off by more than half a millimeter, then we would want to consider doing what's called your X, Y and Z axis calibration. Now there's a bit of work involved in that, and I'm not going to cover it in this video, but there is a recording, there is plenty of recordings out there, and if you want I can always do one for you about how to do X, Y and Z calibration. You're actually calibrating the steps. It's X, Y and Z steps calibration. So the same as you may have heard of E steps calibration. It's the same process as calibrating your E steps, which is your extruder steps. You calibrate how many motions and steps the extruder takes to push out X amount of filament, that's the right amount of filament. You do the same for the other three axes. So most printers arrive straight off the bat and they're very, very, very close to being perfect. Like this, the X and the Y on these are fantastically smooth. I mean, you can't hope for a smoother X, Y, and Z surface for those. They're really, really, really good. I'm super happy with that quality. So just consider that these are the things you want to be looking for. If they're off, go to the forums, talk to people, reach out to me if you wish to. I'll happily guide you through on how to do your X, Y, and Z calibration if you think you need to do the E steps on your X, Y, and Z. It's not hard. If you find there's other quality issues with your print, hit the user forums on Facebook for that manufacturer. Chances are I'm a member of a lot of them, if not all of them, but I'm a member of a lot of them. And there are other people out there who know that specific printer type who would be more than happy to give you some guidance. Now, not everyone's guidance is going to be good. Some guidance is good, some guidance is okay, and some guidance is just downright wrong. So basically, follow the, I wouldn't say herd mentality and believe what the majority of people recommend. But someone who has been on the forums for some time will be able to give you good direction. If it's like, it's hard to find, especially when you first join these groups, to find out what is right, what's wrong. But once you do, you'll figure out that there are some people out there who give really good advice. I try to give good advice. As I said, I may or may not be in that group, but if I am in that group and you find me out there as AstroPrinter, please reach out to me. I'll be happy to try and guide you. And if you really get stuck, you could always call a manufacturer, but they're in China, so chances are you're going to have a bit of a lead time on getting a response.